Swayam Prabha. Digital India. Educated India.
Welcome back, my dear friends. This is the total quality management lecture which I Raghunandan Sengupta from IIT Kanpur is delivering, and today we will have the 6th lecture. And if you remember, the first 5 was more of a conceptual understanding on quality as a philosophy, as trying to bring into the picture such that we always strive for improvement quality. Quality can be improvement of your lifestyle, quality can be improvement on your food habits, quality can be improvement on the way you deliver some work, or the quality may be the way you try to do the household work, maybe the type of work which you do on your shop floor. If you are working as a manufacturing employee in a big unit, it can be on the level of the desk work which you do, consider you are a manager in a company. So, all these things are there, and even though I will be mentioning these words time and again, but still when I come into trying to discuss from the course perspective, it will be more qualitative, quantitative in the way how the concept of quality has been built up. And as I mentioned time and again, our main emphasis would be for the text would be the book of Montgomery. So, considering the and continuing with the discussion of total quality management, management philosophy and company practices that aims to harness the human and material resources and level of competence of the level of human resources of an organization is the most effective way to achieve the objectives of the organizations. The formal definition of TQM as given by the British Standards Institutions are the main targets, which are customer satisfaction, continuous operational improvement, continuous cost reduction, a want to a culture instead of have to a culture. That means, I want to improve, I want to basically do in such a way that the overall philosophy is always one step ahead than what the customer needs. So, rather than customer demanding the services or the products from me in the level to which their satisfaction levels are for the from the customer's point of view, I as a manufacturer, I as a service provider should always be one step ahead, be able to deliver to them when he or she needs it or before that. Main targets of total quality management would be highly skilled workforce. Highly skilled workforce means that he has the level of motivation, he has the required technical skills, he has the required conceptual skills of what quality is, he is conscious that quality is important. He means it can be she also. So, he or she basically is conscious about quality, is conscious that cost should be reduced, is conscious that best product should be delivered in the best possible manner. So, the quality cycle basically consists, I am basically going into the very brief outline and just discuss what are the important points in the cycle. One with the organization, one would be the training required for those set of peoples who are going to manage the overall show or related to quality. There would be the problems and how you identify the problems, there would be problem analysis, how you do the analysis of the problems when you understand where the problem is occurring. Then you propose some solutions, you means the team who is doing that work, then you present and then the feedback is taken and further improvements if required are done. So, the organizations would be about 8 to 10 members in the same area of the shop floor or the same area of the service area. There would be a supervisor or moderator who would basically be looking and how the work is being done. Then the group will process, do some data collection, do some problem analysis, the team and the shop floor. So, say for example, the CNC machine is not working or there is some problem. Not working means not working as per the norm, or the grinding machine is not working, or the furnace is not working, or the paint booth is not working. So, the people who are in that particular area in and around that paint booth would basically do the collective job of data collection and processing the data and trying to analyze what are the implications of the data and how it can be improved considering there is some problem. So, the problem has to be identified. Obviously, this training and when the discussion is going on between the employees at the point who are facing a problem, who want to improve, obviously for them the problem statement is quite crystal clear that what they want to do. You list the alternatives, there is a brainstorming session and people basically give their feedback. Based on the feedback, the overall work for the next stage is started, which is more to do with problem analysis, where you find the cost effect. So, you have the fishbone diagram concept, you to utilize that. Required, as required, we will be discussing that in a little bit later on in the course. There would be Ishikawa's diagram, you will try to utilize those concepts in order to actually understand where the problem occurs and what is the problem and what is the implications. Then after the brainstorming session, after the analysis has been done, the problem solution is stated. Once the problem solution is stated, is basically the implementation and the monitoring of the work. If you remember the pilot project concept which I said, it is taken up in its all its earnestness, and depending on the feedback one gets as a team from running that pilot project, running the implementation, then again the overall process is brought into the picture in the actual mainstream and seen that how it can actually improve the overall process and the quality of the whole system. So, generally there are many reasons for limited success. So, what are the reasons? I will just briefly go through them. There is ineffective training and lack of proper impact measurements, and the actual emphasis which should be there on the employees is missing. So, they have not been either being given the training or they have not been actually told what is the implication of quality and why quality is important. So, obviously, they do not have the motivation to work based on that. Major focus was on customer in integrating quality goals with business goals. So, obviously, the focus was the customer, but the end of the day the implementation was more on the organization. Like yes, customers is important. So, rather than trying to improve the quality, I will try to basically decrease the price and win the market share. Customers are happy initially, but in the long run it will be seen that the customer's dissatisfaction always starts, because the moment they are getting bad quality products, obviously they would protest, market share would decrease. But in the initial phase, as I mentioned, customers are happy, prices are low, it has a positive effect on the shareholder, positive effect on the company, company is doing fine. Later on, when customer dissatisfaction increases, market share decreases, the overall the implication of the cost basically has a negative effect, hence profitability in the company decreases, which is not good. Inadequate use of statistical methods and insufficient recognition of variability reduction is as a prime objective may also be problem. So, if I am not aware that how actually the statistical process control charts can be used, they can be detrimental in trying to give me the information where things are wrong. So, rather than giving me the true picture where quality improvement, where process control improvement, where actual emphasis should be paid, or we should basically emphasize on those steps, the overall focus now shifts to another sphere, where actually rather than considering the real things, we would be more bothered about the secondary factors, which may not actually at all happen in a way that it will basically improve your quality. So, maybe my paint booth we think is a problem, but in reality it may be possible the overall quality of the goods which is coming is an issue. So, rather than concentrating only on the paint booth, if we are able to judiciously and intelligently find out the problem is happening at the vendor's end for the raw materials which he or she is supplying, then it would be a much better way in order to improve the overall quality of the process or the product which you are manufacturing. So, generally general as opposed to specific business results oriented goals, we should be generally be more focused on the quality improvement, but obviously if the focus shifts, and as stated here, these may be one of the main reasons why we have limited success. Too much emphasis on widespread training as opposed to focused technical in education may be a problem. So, we are giving training which is fine, but actually what is the in depth analysis, how the analysis should be done, if that is actually missing, and the people, core people who should be given that training, they are not being given that training. So, obviously, you have not that amount of success which is required. So, educating people, training people is fine, but not giving the proper education training to the core people who will do that implementation part may have limited or negative way of trying to basically pull up the system. Wrapping around ineffective programs like we should always do is have zero defects, quality is free, quality should not it does not come at any cost. So, all these things are jargons which would definitely not have any positive effect or have limiting success on the overall process. So, if we are always saying that quality is free, or we would definitely want some zero defects, which is not possible, because obviously having zero defect would mean that everything is perfect, which means there is no white noise, which in practical sense is not true. So, we should aim in order to the fact that quality should be decreased, we should improve the quality, but in such a manner that it should be within the limits, and if you are able to decrease the level of defects to the maximum possible extent. So, obviously, it would tend towards zero defects, which is a theoretical notion at which we are aiming for. So, we always try to aim for the best possible manner, considering that they are practicality which would have a limitation on our success, but that does not stop us from trying to improve the overall process. Now, having said that, if you remember, I did mention the course would be more an emphasis on probability and more an emphasis on statistical process control. So, I will very briefly go through the concept of what we mean by probability and how probability and different type of distributions would have an implications on the study of quality. So, the basic concepts of probability is that we know probability in a very simple way as the concept of relative frequency, and how relative frequency in the long run basically would give us an idea about probability. So, consider that we roll a die and there are 6 possible outcomes, and consider the die is unbiased actual die. So, all the numbers which are marked on the faces are 1, 2, 3, 4, 5, 6. So, obviously, the experiment could also have been done where rather than have 1 to 6, the faces could have been marked with the alphabets like A, B, C, D, E, F, and so on and so forth. Or say for example, when you are tossing a coin, we actually have an head and tail. Rather than have an head and tail, it could be the coin has been painted one side as black, another side is white. So, whatever the implication is, the actual concept of probability should definitely be very clear from these 2 examples. So, these 6 possible outcomes which we consider are a sample space. Sample space means from the space from where, or from all the observations from where you are picking up the set which is relevant for the experiment when you roll the die or to toss the coin. Consider x is capital X is the random variable which would appear when you roll the die or toss the coin. Toss the coin means the x would basically have 2 values, either head or a tail, or if the color is black or white. And when you are considering x for the rolling the die, the actual x value can be one of the numeric values starting 1 to 6, or the alphabet, say for example A, B, C, D, whatever it is, depending on how you have basically designed your experiment. But one should remember the value of x is unknown to me before the experiment is done. Once the actual face comes up, say for example, when I roll the die and the number 3 comes up, then I will say that capital X has taken a realized value small x which is equal to 3. So, before the experiment is done, x is unknown to me, After the experiment is completed, I know the actual value which I am seeing, and then I assign that particular value to that capital X and say that small x, which is the realized value, is the number 3. So, and corresponding to that I try to find out the probability. Now, when you are basically taking a coin and tossing it 100 times, say for example. So, it may be possible that out of the 100 times, head comes 55 times and tail comes 45 times. So, obviously, the sum 55 plus 45 is 100. In the next case, again when you have basically 100 tossing, and of this unbiased coin which I am talking about, head may come, say for example 40 times and tail may comes 50 times. So, the number of heads and number of tails which we do and when we toss may be different for different experiments as we continue. But the main implication, what we know, that once we toss the coin and the head comes and we say the probability is half or 50%, and when we make the toss and the tail comes and we say the probability of getting the tail is 50%, it means that if we keep repeating the experiment infinite number of times ad infinitum, then the overall proportions of the heads and the tails are equal in number. This, if you think very logically, actually that is the case. Similarly, when you are basically rolling the die, numbers marked 1 to 6. So, obviously, it may mean that in one of the case when you roll it 6 number of times or 10 number of times, it may be possible that 1 comes maximum, 2 comes then, and may be possible number 6 does not appear. In the other case, when we roll the die, the same die, if 100 number of times, it may be possible that only 6 number comes, other number does not come. But if we keep repeating the experiment as we did for the unbiased coin, it would be seen that the proportions or the relative frequency or the probability means in the long run, as basically the number of such events or number of experiments which you do basically becomes infinite, then it will be seen the actual probability of the numbers coming either 1 or 2 or 3 or 4 or 5 or 6, considering the fact it is basically an unbiased die, the probabilities would be 1 by 6. So, as mentioned in the 4th bullet point, the probability of capital X taking the value small x, which is equal to 5, is basically equal to 1/6, which means the number of favorable outcomes divided by the possible number of outcomes which has come. So, in the ratio which we have, in the numerator we have the number of favorable outcomes which basically adheres to the fact the number 5 has come, and in the denominator we have the total number of such tosses which has happened in the long run. So, the number of tosses in the long run, if it tends to infinity, obviously the numerator will also increase, but in the long run the overall ratio of the numerator to the denominator for this example will tend towards 1 by 6. So, to analyze this type of problems, we will basically have a probability distribution function which can be thought of as a mathematical function which gives the probability or the functional mapping of what is x, what is the value of x comes, and what is the overall relative frequency or the probability of that value coming out to be x. So, it basically is a mapping depending on the realized value and what is the overall function and implication between the x value and the probability. So, probability function which we said basically can be of two types. One is the probability mass function for the case when x is only discrete. So, the examples which we had discussed in the last slide, where when you are tossing a coin or basically rolling a die, then the values which are coming out is discrete, but considering the case when you are trying to say for example measure a length or measure the total quantum of say for example fluid which is flowing at a particular unit time, obviously the fluid flow rate is not deterministic, or the height or the length of a person or say for example of a tie rod. So, height would be as I mentioned for a person and length would be for a tie rod. When you are measuring, they would basically be, it's possible theoretically that they take all the values between say for example 0 and 12. In that case, we will be saying that the distribution function based on the random length or the height would be continuous, in the sense x would take all continuous values. Hence, we will be saying that the probability function which we will be utilizing would be used by the word of probability density function. So, in the first case when it was x was discrete, it was probability mass function. Why the word mass? Because the concentration of the probabilities are at any particular points depending on what the x values are, and probability distribution function would be the case when x are all continuous. So, probability distribution functions can be discrete or continuous density functions which I mentioned, where the values comes out to be basically from 1 to 6. Continuous when the sample space consists of continuous numbers like the temperature in the room. It can be any continuous value between 15 to 50, or 15.51 can be one value, or say for example 15.5126 can also be a value depending on how accurate your temperature measuring equipment is, or it can be 16.72. Consider the two just examples or the notions which I gave. When you are measuring the height of a person can be 5.125 meters feet, sorry, or the height of say for example another person can be 5.1369 feet. When you are measuring the tie rod, say for example the tie rods can be between 12 to say for example 13 feet. So, it can be 12.025 feet also, it can be 12.7562 feet also. So, depending on the accuracy they can be any continuous values between the range what I have mentioned for the tie rod. So, for the discrete case the probability distribution function is basically denoted as probability mass function as I mentioned. For the continuous case it is mentioned as probability density function. So, this is the probability mass function which I have. So, the outcomes or the realized values are measured along the x axis which you see. So, this is the x axis where I have, this is the x axis and these are the outcomes. So, the outcomes are measured, and this is not the example which I have when I am talking about the tossing the coin or rolling the dice. And along the y axis you basically would plot. So, those two figures which I am going to mention now are not there, but based on those we get the probability mass function. First you will try to basically have the frequency along the y axis, then utilize the concept of relative frequency along the y axis, and if you remember the concept of probability basically comes from the concept of relative frequency, where in the ratio of the relative frequency we have the number of events which are favorable divided by the number of total events, and as the number of total events tends to infinity, hence the relative frequency becomes the probability. So, if you consider this diagram, along the y axis you have the probability, and the histogram, this is the histogram, looks like a normal distribution, and this is the notion why I purposefully brought a histogram in such a way that somebody would understand the implication of normal distribution and the whole amount of utilization of normal distribution we will be utilizing for our total quality management course. So, this is the PDF, as I mentioned, this is the PDF of the normal distribution on the bell shaped curve. So, the above graph, if you see the graph, the mean value which is the central value is given as 0. So, I am not going to go to the details, but I am going to give you a brief outline that why the diagram has been drawn this. This is the standard normal deviate distribution curve, which when we try to utilize the x value as the discrete or the continuous random variable for the PMF or the PDF, but for the case when we come to the utilization of x as a continuous random variable and try to plot the normal distribution, then the mean or the median or the mode value which is the central value for x need not be 0, it can be anything. Say for example, when you are measuring the height, the average height or the mode or the mean value basically can be, say for example 5.25 feet, or when you are basically measuring the tie rod, it can be, say for example 12.766 feet. So, those values which you consider using the simple transformation from the normal distribution to the standard normal deviate, the graph which you get is shown in this slide, which is the standard normal deviate, with a mean value of 0 and the standard deviation of basically 1. So, along the y axis you are measuring the probability, along the x axis you are measuring not x, but z, which is the standard normal deviate random variable. So, the above graph shows the probability distribution for a set of outcomes referred to as z values. So, if you remember just few seconds back I mentioned that x has been transformed to z with the standard deviate random variable, and we are trying to plot the standard deviate random variable along the x axis, and along the y axis we have the corresponding probability to the fact that how as z changes and it takes the realized value of small z, what is the probability along the y axis. From the graph it can be said that the probability of when small z is 2, that means the realized value is known to us, and when realized value is known to us as minus 2, if you see the probability values are equal. The reason being it is a dumbbell shaped curve which is symmetric and is equally dispersed along the mean value which is 0. So, if you move the same quantum on to the right, that means plus 2, and same quantum on to the left which is minus 2, the overall probability values would definitely be the same. So, what if you want to find out the probability of z is greater than 2 or z is less than 3? So, obviously, we know that the distribution curve PMF or the PDF is such that the overall area underneath the curve would always be 1, because the probability sums is always 1. So, if you have the discrete case you will basically sum it up, and if it is a continuous case you will basically integrate. So, integration and summation are the same concept. So, when you want to basically find out the value of z is 2, obviously it would be the sum of all the z values starting from z is more than 2 till the infinite value, because if you see the graph here which is being displayed now, the z value basically can take any value starting from minus infinity, which is on to my left hand side, to plus infinity which is to my right hand side. So, any values adding up starting from z is equal to 2 till the infinite value would give me the first value, what is the probability that z takes a value greater than 2. In case if I want to find out that what is the probability that z takes a value of less than 3, so I can give you two ways of how you do the calculation. One would be basically to add up all the values starting from minus infinity till z is equal to 3, or another implication would be by how you do the calculation would be to first find out all the probability sums starting from the fact that z is equal to 3 till infinity, and once you add that, subtract that value from 1, because the total value under the curve is always 1. So, 1 minus that would give me the next value, which is probability of z is less than 3. Now, CDF value, which is the cumulative distribution function, is basically the sum of the PDF and the or the sum of the PMF. So, it gives the probability at a point of the continuous and discrete events. What if you want to find out the probability of a set of events, as just mentioned in the last graph, where the probability is to be found out for z value greater than 2 or the z value less than 3, for these two examples. Say for the normal distribution we want to find out the probability of z is less than 2, the probability would be equal to the sum of all the probabilities from minus 6, that is the leftmost point. So, obviously minus 6 is being shown because other values cannot be shown here, but technically they are from minus infinity till that value of z. The probability distribution which shows the sum of the probability up to the point are termed as the cumulative distribution function, and this concept of cumulative distribution function would be the same for the PMF or the PDF. So, with this I will end this 6th lecture and continue the discussion about probability distribution functions, probability mass functions and CDFs, and see that how these concepts can be utilized in statistical process control later on. Have a nice day and thank you very much.